Welcome pre-cal students to class today, the next to last video of the year, so I know you guys are excited about that on this May 14th. I hope you guys are doing well, and I hope you're ready to go over some math. I really don't have a lot to say as in terms of announcements. Don't forget I will give you a test on Friday. I will email that to you, and you're welcome to take it on your own and then come over and ask questions, or you can set up a time to take the test at my house. If you do that, we're going to go next week. Let me tell you what's going on this week for me. Friday is class day for my daughter at GPS, so I will not be available this coming Friday, obviously. And plus, I've got my parents coming in from Ohio, and Linda's parents are coming in from Florida. Jessica has graduation on Saturday, and we have a reception here at our house for her, so I won't be available until next week starting on Monday. But anyways, I will send a test to you on Friday sometime. And then if you want 5 bonus points, don't forget to take notes on everything that I say during the videos and turn that in when you turn your test in, and I will give you 5 bonus points on your test. That's a really good deal. You've got to listen to the videos anyway, so you may as well take notes and turn that in. And then lastly, your tests are due today. Please don't forget that. Keep that in mind, okay? We're going to start for the next 2 days. Today and Thursday, we're going to start looking at a bunch of equations. And you know what scares me? What scares me the most is whether or not you'll have the ability to look at an equation and know what type it is, because they're all going to be bunched together, and I'm doing that on purpose to make you prove to me that you recognize these different types of equations. And so make sure as you take notes on this, you're listening to what I'm saying about each one. For example, let's go ahead and get started. On these two, by the way, we're going to do about 15 problems today, okay? Now look, you should recognize right away this is a linear equation. Both of these. I mean, look at your exponents for your x. There's a 1 here, a 1 here, there's a 1 here, and a 1 here. There's no inequality symbol right here like a less than or a greater than. There's no square roots or exponents up here or logarithms. It's just a good old-fashioned linear equation, okay? And so let's go ahead and solve these very quickly. Of course, for this problem right here, you would bring the negative 4 over and make it a positive 4, and then you would bring the 5x over and make it a negative 5x. Okay, so 3 and a negative 5 is a negative 2x, and 8 and a 4 is a 12, and now divide both sides by negative 2, and x equals negative 6. Wouldn't it be great if they were all this easy? It's really simple. Alright, let's take a look at this problem over here. Now, the main thing you need to remember about linear equations is you first of all do your simplifying. You want to simplify the left side and simplify the right side if you can. Now, over here, there was no simplifying we could do. They're unlike terms, and there's no simplifying here. They were both unlike terms. Here, we're going to take the 5 and multiply it through. 15x. And by the way, let me say this. If you're watching this video right now and you're like, I know how to do this, well then finish the problem on your own and then fast forward to the end of this problem and make sure you got it right. I mean, that's fine. You say, what about taking notes? Well, if you work the problem out on your own and get it right, then you've taken notes. Look, if you can work a problem faster than I can explain it, which you probably can, then go ahead and do that. I have no problem with that at all. So definitely do that. Let's continue on. Let's see, 15x plus 5, 2x minus 8. Bring your 2x over and make it a negative 2x. Bring your 5 over and make it a negative 5. And you're left with 13x equals negative 13. Now divide both sides by 13, and you will get negative 1 for x. I better check these very quickly. Negative 1, well, we'll assume they're right. So, okay, there we go. So there will be some nice, simple linear equations on your final exam. Now, there will also be some multivariable equations, okay? And so let's go ahead and take a look at these. For example, in this multivariable equation here, they want us to solve for h. Now, there's different goals I can give you, but pretty much you have to take each equation as it is and kind of figure it out. For example, you should see this right away. You should see it's a multivariable equation for two reasons. First of all, I have more than one type of variable, and number two, I'm telling you what variable to solve for. You should see right away there's no way you want this radical. That radical's in the way. And so if I square both sides, I will get rid of the radical. So if I square the v, I'm left with v squared. And if I square a square root, I'm left with what's under the radical. There. Now, we're solving for h. Now, please don't miss this, students. Look, if I had a plus sign right here, then I would have two terms. Here's one term, and here's the other term. And I would simply pick this term up right here, this 2g, and I would bring that 2g, that's not going to work, I would simply pick up this 2g, bring it to the other side and make it negative, and I would have v squared minus 2g. Okay? If I had two terms over here. But I don't have two terms over here. I have one term. There's no plus sign right here. So this is all one term. You just can't pick up the 2g and move it to the other side. What you have to do to get h by itself is divide by 2g. So if I divide the right side by 2g, those cancel, leaving me with h. And on the left side, I would have v squared over 2g. Now I know I'm finished because h is all by itself. Okay? Now when I look at this problem here, I know it's a multivariable equation because I have more than one type of variable, and also it tells me what variable to solve for. I'm solving for t. Okay? And so, I mean, as soon as I see, I'm not sure why it doesn't say equals anything. Let's change this problem and make it equals 5. So 1 over a plus, all of these problems are from past tests. So if you want to get out your old tests, you can do that. Let's just say it equals 5. I'm not sure what we said on the test, but there we go. Okay, now, I mean, to me, the first thing I want to do is get rid of my fractions. I mean, I don't want these fractions. Well, a common denominator for a, b, and t is abt. So I'm going to multiply the entire equation by abt over 1. Now if I multiply this fraction times this fraction, your a cancels with your a, and bt times 1 is going to be bt. So I'm going to go ahead and put bt. Now I'm going to multiply this fraction times this fraction. Your b will cancel with your b, leaving you with at times 1. And so now I'm left with a, better put a plus sign here, plus a t. And now I'm going to multiply this fraction times this fraction. Your t would cancel with your t, leaving you with ab times 1, which is ab. So now I have plus ab. Now here's where a lot of students forget. They forget to multiply the fraction times the right side also. And abt times 5 would be 5 abt. Now, we got rid of the fractions. Good. Now, over here in this problem, we only had one term with an h. 2gh had an h. Over here, we're solving for t, and I've got three terms with a t. 1, 2, 3. So if I'm solving for t, I need to get all of those terms on one side and move all of the other terms to the other side. So here's what I'm going to do. Okay, I'm going to bring the AB to the right side because it doesn't have a t term. Now when I bring it over here, it will become negative. There we go. Now I'm going to bring the 5AB over here, and when I do, it's going to become a negative 5AB. Alright? So we're going to slide it right over here. And of course, all of that equals negative AB. Now, we're still solving for t, so the next thing you want to do is factor out a t. By doing that, it gets t all by itself. So I'm going to factor out my t, and I'm left with b plus a minus 5ab. And now look how close I am, students. All that I have to do, let me go ahead and do this real quick to save time. All that I have to do is divide both sides, and I really need to get some extra space here. all that I have to do is divide both sides by this right here. There we go. And of course this will cancel. Now I will be left with t equals negative AB over this right here. And there we go. Do you need the parentheses? Not necessarily. I mean, you can leave them. It doesn't hurt anything. I don't care. A lot of students do this and they're like, oh, cross off my A and cross off my B. And I've taught you this a million times. You cannot do that unless you have one term in the numerator, which we do, but you also must have one term in the denominator, and we don't. We have three terms, okay? So there we go. There's your answer. So multivariable equations will be on your exam. I better not say will be, they could be, okay? They could be, very well could be on your exam. Alright, now let's take a look at some equations that are not linear. You should recognize these right away, guys. Okay, look. Let's start off with this problem here. Let's get some space here. Alright, now right away, you should see that this problem here is not linear. And you're like, well, Mr. Earhart, how do you know that? Well, I'm glad you asked. If you were to multiply this out, you would get 6y squared, positive 15, negative 2, positive 13y, minus 2, let's see, minus 5. Okay? It's a second degree. It's a quadratic equation. You can see that because of this exponent right here. You need to learn to recognize these. As soon as you saw that, you should realize, as soon as you realized you had two parentheses and they each had a y in it, that's not going to be a linear relationship, okay? This is a quadratic. Now, what's so nice about number 9, let's not forget, when you're solving equations that are second degree or third degree or fourth degree or fifth degree, your number one choice is always to factor. Now, sometimes you can't, but try to. And then if you can't factor, if it's a quadratic equation, use the quadratic formula. And I'm writing it so you don't have to look it up in your notes. Okay? If it's not a quadratic equation like this one here, and you can't factor it, then you know what you're going to have to do? The nasty, nasty job of listing out the possible rational zeros, and then using that synthetic division like negative 2, and you'd put a 3 and a 1 and a negative 12 and a negative 4, and you have to go through and test numbers until you found a 0, and that would be one of the solutions. Now, I don't plan on giving you any like that, but I'm just saying that's how you're going to have to solve them, okay? Now, here's what's so nice about number 9. Guys, it's already factored for you. So all that you have to do is take the first parentheses, set it equal to 0, take the second parentheses, set it equal to 0, and solve. So this here, bring the 5 over, make it a negative 5 and divide by 2, and you get a negative 5 halves. Over here, bring the 1 over and make it a positive 1 and divide by 3, and you get 1/3. So just like that, we're done, okay? When it's already factored, then we're good to go, as long as the right side is equal to 0, and it is, all right? Okay, moving on to the next problem. Okay, let's take a look at this next problem here. Now, this one here is a quadratic equation. It's not linear, and you can see that because of the 5x. You see the x squared right there, okay? So with that in mind, you could try to factor it, but I'm going to be honest with you, when you see just an x squared, the best thing to do is get the x squared by itself and then take the square root of both sides. Watch, if I divide both sides by 5, I'm left with x squared equals 3. Now take the square root of both sides, and you're left with x equals plus minus square root of 3. If you only have an x squared and there's no x terms anywhere in the equation, just combine all of your x squared terms and then use the square root method. It's the fastest way to solve these, okay? All right, let's take a look at this equation here on your test. You should recognize this right away as being a quadratic equation. And so the first thing you want to try to do is you want to try to factor it. So bring the 5 over and make it a negative 5. It does no good to factor unless the right side is equal to 0. Now, what two numbers multiplied together give you a negative 5, when added together give you a positive 4? Well, that's going to be a 5 and a negative 1. If you multiply those, you get a negative 5. If you add those or combine those, you get a positive 4. So the factorization is going to be x plus 5x minus 1. And now, what solution would satisfy this equation? Negative 5. And what solution would satisfy this? I said equation, sorry. What solution would satisfy this parentheses? Negative 5. And what solution would satisfy this parentheses? A positive 1. And there we go. We're finished. So you should try to factor these equations when you can. And then last but not least, here's a third degree equation. Okay, well, again, let's try to factor this. Okay, maybe we can, maybe we can't. It's a 4-term expression, so we've learned to always pull out what's common in the first two terms. So I'm going to pull out an x squared. When I do that, I'm left with 3x plus 1. Now we're going to pull out what's common in the next two terms right here. Now remember, when this term right here is negative, then whatever you decide to pull out is going to be a negative. So I'm going to pull out a negative, and then of course the thing that's common is 4 goes into both these numbers, so I'll pull out a 4. Now what I always suggest to students is, instead of trying to figure out what goes in here, just copy this and see if it works. And if it works, you're fine. If it doesn't, then it can't be factored. Let's see if it worked. What's a negative 4 times 3x? Negative 12x. What's a negative 4 times 1? Negative 4. So this factorization right here did work, and so we're good. We're going to continue on. If your parentheses did not match, then you couldn't factor it. But our parentheses do match. And so we can factor it. Now this can be factored again because we know the square root of x squared and we know the square root of 4. So really now what we have is 3x plus 1. And then I'm going to split the last parentheses down into two parentheses. And in that parentheses, the square root of x squared is x. So I'll put an x here and an x here. The square root of 4 is 2. So I'll put a 2 here and a 2 here. Make one positive, make one negative. And now, what solution would satisfy this parentheses here? Well, a negative 1/3. If you take 3x plus 1 and set it equal to 0, you'll get negative 1/3. What solution satisfies this parentheses? A negative 2. And what solution satisfies this parentheses? A positive 2. There we go. Okay, so there's your 3 solutions to this third degree equation. Now let's take a look at this problem here. On the test, I could very well give you a problem in which the directions say solve by completing the square. In fact, there's a good chance I will do that because you need to know how to do it. Okay, so we're going to solve by completing the square, and here we go. I will break these steps down to you, or down for you one by one. Okay, step 1, I'm not going to write them, but you can write them down and pause the video. Completing the square is a very difficult procedure, so you might want to get your notes out and look them up, or you might want to just write the steps down now. Step 1, you want to move all of the constant terms to one side and all of the x squared and the x terms to the other side. So if I do step 1, it will look like this. You cannot forget to do this, okay? There we go. Step 2 states whatever is with the x squared, or whatever your x squared coefficient is, you divide the entire equation by that number. In this case, the x squared coefficient is 3, so I'm going to divide every term by 3. That's easy. We can do that. So here your 3's cancel, and you're left with x squared minus 4x equals 2. Now, the next thing you're supposed to do is take your x coefficient, right here, your negative 4, and you multiply it by 1/2, or you could also say divide by 2. It's the same thing. If you divide by 2 or multiply it by 1/2, it's the same thing. So we take this number here and we divide it by 2 or multiply it by 1/2, whatever you want to call it, and then whatever you get, you square it. So let's do that up here. It doesn't really matter about the sign. I'm not going to worry about that. I'm going to take the 4 and I'm going to multiply it by 1/2, and when I do that, I get 2. And then I'm going to square that, and I get 4. So whatever number you get out, you're going to add that to both sides. So now I have x squared minus 4x plus 4, and then over here I will have a 6 because 2 plus 4 is 6. So whatever number we get up here, we're going to add that to both sides. Now the next step is to factor the left side. Now listen, you normally can't factor the way I'm going to show you, but there is a shortcut when you're completing the square. Now this shortcut only works when you're completing the square, and the shortcut goes like this. Whatever this term is here, take the square root of it, and you put it here and here. Whatever this number is, take the square root of it, and you put it here and here. And then whatever the sign here of your middle term is, you put it here and here. Okay? So there, you factored it. Now after you're done factoring, the next step is to, by the way, these two parentheses will always match. Okay? If they don't, you've made a mistake. And so since those two parentheses match, what you do next is you write the left side with a power of 2. Excuse me. Okay? And now here's what you've done. Let me show you what you've done here, okay? This is really cool. Now look, you have taken this original equation right here and you've totally changed what it looks like, and now it looks like this. Now to me, that's really cool. Okay, you did all this work and you changed what it looks like. And why is that a big deal? Because you have a group to the what power? Second power. So you have learned anytime you want to get rid of a power of 2, you can take the square root of it, as long as what you do to one side you do to the other side. There we go. So when you take the square root of something squared, you're left with just the base. So x minus 2 equals positive negative square root of 6. Now bring the negative 2 over and make it a positive 2. And so your final answer is positive negative square root of 6 plus 2. Now that's sufficient for me. That's totally sufficient. I will say this, if this would have been like an 18 right here, I would expect you to break the 18 down into 9 times 2 and then cross off the 9 and put a 3 right here. Okay, so always look to see if you can simplify radicals. You're also welcome to, if you want to type it into your calculator. I have no problem with that. Okay, and so I'm trying to see if I have my calculator close by. You can do that if you want. The square root of 6, enter, plus 2. So it looks like one answer would be 4.4 rounded, and then I would take the square root of 6 and then multiply it by a negative 1 to get a negative sign right here, and then plus 2, and I would get a negative 0.4 for my other answer. Either one of those is fine. It really doesn't matter to me, but the main thing you need to be familiar with is be able to complete the square on your test. Okay? All right, let me get a drink here. And we'll continue on. All right, let's take a look now at another problem. On the test, make sure you are able to solve a quadratic by using the quadratic formula. Okay? So you do need to know the quadratic formula. And here it is again. I gave it to you earlier. Negative b plus minus the square root of b squared minus 4ac all over 2a. Now, number one, you never want to use the quadratic formula. Please don't forget this, guys, unless the right side is equal to 0. And in this equation here, the right side is not equal to 0. So I'm going to move the negative 4 over, and when I do, it will become a positive 4, and I'm going to set that equal to 0. Good. Now, whatever is in front of your x squared, whatever the coefficient of the x squared is always your a. Your x coefficient is b, and your constant term is c. So here we go. Negative b. Well, b is 3, so negative 3. Plus minus the square root of b squared. Well, b is 3, so I'm going to put a 9. And then what I like to do is I put negative 4 and then squeeze my ac in. ac. A is 3, c is 4. 3 times 4 is 12. All over 2 times a. Well, a is 3, so 6. Okay, now let's continue. Next I would have negative 3 plus minus or positive negative 9 minus 48. You do your multiplication first. So negative 4 times 12 is negative 48 all over 6. Okay? Now let's continue over here. Negative 3 positive negative square root of negative 39 all over 6, because a positive 9 and a negative 48 would be a negative 39. Now, at this point in time, you should realize you cannot take the square root of a negative number. So what I've taught you to do is to make the radicand, that's the number on the inside, make it positive as long as you put an I on the outside. Now, I'm trying to think, there's no numbers, there are no perfect squares that go into 39 evenly, and so you really can't simplify the square root of 39. Notice the I is outside the radical, please don't miss that. But we really can't simplify the square root of 39, and a lot of students would like to cross off the 3 and the 6 and reduce. Don't do that, because you have two terms up top. Now, if there was a 9 right here on the outside and you wanted to reduce this number and this number and this number by 3, that would be totally acceptable, okay? But you do not reduce an outside number with an inside number like 39. Do not do that, okay? So really, this is as far as you can go. There's nothing else you can do with this, okay? So there we go. That is your answer, okay? All right, so make sure you can solve quadratic equations by using the quadratic formula and also by completing the square. And now we're going to do some more factoring. So let's go ahead and do some more practice here. I want you to solve this equation by factoring, okay? And actually, there should be a 0 here, so we'll go ahead and put a 0 right here. All right, now I'm not sure what happened here. Hold on one second. Okay, there we go. All right, now, well, look, you have a quadratic equation, so the first thing we want to do is try to factor it. Notice I do not have a lead coefficient of 1. I have a lead coefficient of 15, and I'm wondering here, I'm thinking, students, and I apologize, I wonder if I got the wrong problem here, Caleb, Matthew, because let's see, 15, 10, 5, 3, positive 15. Let's just make this a positive 8. I'm sorry to do that, but we're going to have to make it factorable, and I'm not sure what happened there, but let's just fix the problem. There we go. Okay, so let's solve this by factoring. Now, I know we've done something like this earlier, but the ones we did earlier did not have a coefficient here with the x squared. And so what I'm going to do here is I'm going to refresh your memory on how to factor these. So we take the 5 times the 3 and we get a positive 15, and we say to ourselves, what two numbers multiplied together give me 15 when added together give me 8? Well, obviously it's going to be 5 and 3, because 5 times 3 is 15 and 5 plus 3 is 8. So watch what I do. I don't write 8x, I cross that off, and in place of that I'm going to put 5x plus 3x. And then put a positive 3. Okay? Now, we're ready to factor. Pull out what's common in the first two terms, which would be a 5 and an x, and you're left with x plus 1. Now pull out what's common in these last two, which is a 3, and then like I've taught you, whatever you wrote right here, write that over here and see if it works. 3 times x is 3x, 3 times 1 is 3. So we're good. We write our matching parentheses once, and we write what's on the outside of those two parentheses next. And now, what solution would satisfy this equation? A negative 1. And what solution would satisfy this parentheses right here? Well, if you set this equal to 0, brought the 3 over and made it negative, and divided by 5, you would get negative 3/5. So there we go. We solved a quadratic equation by factoring. Now, if you'll look at the last problem on this page here that we're going to look at, this one is a little different, but I wanted to refresh your memory about something, okay? I wanted to remind you that whenever you have a trinomial, and we do, 1, 2, 3 terms, and whatever your power here is, if it's twice as big as this power here, and you have a constant term here, you might be able to factor it using your typical trinomial factoring rules. So, and again, I'm not sure what I was thinking, guys, and I apologize. It's kind of humorous. I'm not sure if I was half asleep when I pulled these off the test or what I did here, but we're going to have to change this one real quick here. And again, I apologize. Let's see, a positive 3, so that'd have to be something like 10. Okay, there we go. All right, let's go ahead and solve this equation by factoring. Now you should notice it's a 4th degree. Notice we have an exponent of 2 here. So this exponent here is half of this exponent, or you could say this exponent here is twice as big as this exponent here, and we have a constant term here, and it's a trinomial. So we're going to use our normal trinomial factoring rules, and we'll see what happens. Notice I have a lead coefficient of 1 here, so I'm going to say to myself, what two numbers when multiplied together give me 10, when added together give me a negative 3. Well, I'm thinking of these two numbers right here. If you multiply those, you get, actually, let's make this a negative 10. And again, I'm really sorry, guys. I'm not usually like this. You know that I'm pretty organized, but I'm not sure exactly what I was thinking. But if you multiply these, you'll get a negative 10. And if you combine them, you get a negative 3. And so now what we have is, now normally you would put an x or a y here, but because your middle term is a y squared, we're going to put y squared minus 5, and then y squared plus 2. And now, if you take each parentheses and set each parentheses equal to 0, first parentheses here, second parentheses here, you will get out your answers. For example, if you take this parentheses here and set it equal to 0 and solve, you will get this for your answer. Go ahead and do that and you will see. You'll bring the 5 over, make it a positive 5, and take the square root of both sides. If you take this parentheses and set it equal to 0, you'll bring the 2 over, make it a negative 2, then you'll take the square root of both sides, so you'll have the square root of a negative 2. So the answer to this part of the equation would be positive negative square root of 2, and then I. Okay? And there we go. So I do apologize for a little bit of the confusion on my part here with some of these problems. I'm not sure what I was thinking, but what I wanted to go over on this problem is, don't forget, you can factor trinomials that are not always a power of 2. Sometimes it'll be a power of 4 or 6, as long as this exponent here is twice as big as this exponent here, and as long as you can find factors of this number here that combine to this number here, like we did right here, negative 5 and positive 2, then you can factor it. Okay? All right, let me get a drink here, and we have one more page. Now, this next page is not easy, so understand. You're like, oh, there's only one page left. Yeah, but there are 3 problems, and they're pretty challenging. So let's go ahead and get these done, okay? Now, when you see these on your test, you should recognize right away they're just not inequalities. They're they're non-linear inequalities. For example, this is a second degree. This is a second degree. If you were to multiply all this out here, you would get a third degree. A linear inequality is simple, and we're going to have some of those later. Something like this. 2 at 2 times x minus 3 is greater than or equal to 5. I mean, that's called a linear inequality. My goodness, you just multiply the 2 through, bring the 6 over, and divide by 2. Just like a regular equation, linear equation, and you're finished. But that is not the case with these types of problems here. And we just covered these on your next to last test, I believe, so let's really take some good notes here, okay? The first thing I taught you to do is you rewrite the equation with an equal sign. And then you solve it like it was a normal equation. So what I'm going to do is I'm going to bring the 9 over and make it a positive 9. And then take the square root of both sides. So there, I solved it like a normal equation. Now remember what remember what your solutions are called? They're called critical values, okay? And what you do next is you take your critical values and you put them on a number line and you test regions. That should ring a bell, okay? And I encourage you not to put 0 on your number line because you're going to think it's one of your critical values. So here's one of your critical values. Here's the other one. Look at your original equation. Was there an equal sign right here? No. So you do not shade these 2 points in. Don't do that. They're open. And now look what you have. You have 3 regions. You have a region here that you need to check. You have a region here that you need to check. And you have one here that you need to check. And I would encourage you to check them here in the original problem. So let's check the red section first. Look, any number over here will work. You can use -4, -5, -1 million. I'm going to test -4. So where the x is, I'm going to put -4. And let's see if I get a true or false statement. I get a positive 16. -4 times -4 is 16. 16 minus 9 is 7. 7 is less than 0. That's false. That is not true. So this section here did not work. All right. Now let's go ahead and test the green section. I'm going to test 0. Why not? That's the easiest number to use. 0 squared is 0. 0 minus 9 is -9. -9 is less than 0. That is true. That works. I'm going to put a big old check mark here. That's good. And now let's check our last region. We're going to call it the blue region. And we're going to use 4. You could use 5 or 6 or 10 or positive 1 million if you want to. Well, if you square 4, you get 16. 16 minus 9 is 7. You get 7 is less than 0. And that's false. I would like you to write your answer on the test in interval notation. So the only region that works is this region here, the green region. And so notice it's non-inclusive, so I'm going to use a parentheses. Non-inclusive, so I'm going to use a parentheses. It's a bounded region. In other words, this was an unbounded region over here. It kept going on and on and on. And this is an unbounded region over here. There's no critical value that stops this region, so it goes on and on. This is a bounded region. It stops here and it stops here. So the solution lies between -3, comma, and +3. Notice the parentheses means non-inclusive. 1 down and 2 more to go. All right. So these are non-linear inequalities. The last one was a quadratic inequality. This one is also a quadratic inequality. Step 1, you solve it like it's an equation, even though it's not. So put an equal sign in there. And now, if I gave this to you on a test or a quiz, you should recognize it right away as a quadratic equation. So you want to get one side equal to 0. Now let's see if we can factor this. We do not have a lead coefficient of 1. We have a lead coefficient of 2. So 2 times -2 is -4. What two numbers when multiplied together give you -4? When combined give you a -3. Well, that's probably going to be this right here. If you multiply those two numbers, you will get -4. If you combine them, a -3. So I'm going to go really fast. We really should know how to do this by now, so I'm going to go really fast. This is old review material. Okay, pull out what's common here, 2x. You're left with x minus 2. There's nothing common here, so pull out a 1, and you're left with x minus 2. And then the final factorization would be x minus 2, 2x plus 1. Okay, now what number would satisfy this parentheses? A positive 2. And what number would satisfy this parentheses? A negative 1/2. A negative 1/2. So your critical values are 2 and negative 1/2. So you take your critical values and you put them on a number line. Okay, so negative 1/2 would be over here to the left, and 2 would be over here to the right. Notice these values are open. There's no equal sign right here under the inequality, and so we're going to leave it like that. Now let's go ahead and quickly section off our regions. We have a black region right here, and we have a red one right here, and we have a green one here. And here we go. For the black region, I'm going to test. You could use a fraction. You could use negative 1 1/2, negative 3 1/2, negative 5 1/4. I'm going to use negative 1. Negative 1 is to the left of negative 1/2. So if I put a negative 1 here and square it, that's 1. 1 times 2 is 2. Put a negative 1 here, that's a negative 3. Negative 3 plus 2 is a negative 1. Is 2 greater than negative 1? Definitely. So this quadrant right here checks. We're good. Now let's test the red quadrant. And 0 is a great number to use when you can. 0 squared times 2 is 0. 3 times 0 is 0 plus 2 is 2. 0 is greater than 2. That is totally false. Okay? And now let's check our green region by putting in a 3. Okay? All right, here we go. 3 squared is 9 times 2 is 18. 3 times 3 is 9 plus 2 is 11. 18 is greater than 11. That is definitely true. Definitely. So there we go. So what we have, I'm going to get rid of this. Just give me a little space here. What we have then is two quadrants that work. Notice both of them are unbounded. This one continues on and on to the left. This one continues on and on to the right. So the answer for this region here would be, always use parentheses with infinity. It would be negative infinity, comma, up to negative 1/2. Put parentheses for the negative 1/2 because you have an open point right here. And then for this quadrant here, parentheses and then a 2 because the 2's open, so use parentheses, and then going on to infinity. And there we go. There's your answer. All right, one more left, guys. So we're finally done with today. Then one more video tomorrow, and I can hear the cheers from Matthew's house all the way over here to Castle View. So, all right, let's take a look here. All right, now this is a non-linear. Let me get a drink here. This is a non-linear inequality. And I know it's non-linear because think about it, guys. And you should recognize this by now. If you multiplied this parentheses times this parentheses, you would get a negative x squared. And then whatever you get here, multiply by this parentheses, you get a negative x cubed. If you were to multiply all of this back out, your degree would be a third degree. You should know how to look at that and kind of sense that, okay? So with that in mind, this is a non-linear inequality. And if it's a non-linear, then the first thing we do is we rewrite the equation with an equal sign, just to get our critical values. And then we usually want to factor. Well, guys, it's already factored for you. So if you took this parentheses here and set it equal to 0, you would get a negative 1. That would satisfy this parentheses. I don't think that's right. No, I'm wrong. It would be 1. And if you don't see that, take 1 minus x, set it equal to 0. Bring your 1 over and make it a negative 1. Negative x equals negative 1, so x equals 1. Or you could have just brought your x over and made it a positive x, and 1 equals x. Either way, you get 1. So that one's a little difficult to see. So for this parentheses, the solution that satisfies it would be 1. The solution that satisfies this parentheses would be a negative 4. And the solution that satisfies this parentheses would be a positive 2. So we have 3 critical values. So a little more work, but that'll be fine. Negative 4, and then 1, and then 2. And notice I don't care if they're spaced out consistently. Just put the numbers up here so you can see the regions. Notice we do have an equal sign here, so I am going to close all of these points real quick here. And now we have quite a few sections here. We've got we'll call it, we got our black quadrant over here. We have our red quadrant here, our green one here, and our blue one here. And I do that so we can talk intelligently about which quadrant we're on, okay? All right, let's start over here to the left. I'm going to use negative 5. If I put a negative 5, and I'll be careful, there's already a negative sign here, put a negative 5 in, and a negative would be 5 plus 1, you would get a 6. Then put a negative 5 here, you get a negative 1, and then put a negative 5 here, you get a negative 7. You can do the multiplication. The main thing you want to see is, do you get out a positive or a negative number? Because a negative number will be less than 0, and a positive number will be greater than 0, okay? So 6 times negative 1 is negative 6 times 7 is a positive 42. So you're getting out 42 is less than 0. That's not true. Okay, 42 is not less than 0, so this quadrant here does not work. All right, let's try this quadrant here, the red quadrant. We're going to test 0, because 0 is a number that lies between negative 4 and 1. So 1 minus 0 is 1. 0 plus 4 is 4, and 0 minus 2 is negative 2. If you multiply all those together, you will get a negative 8. Negative 8 is definitely less than 0. So this quadrant right here checks. All right. Now, be careful here on this one. You're going to have to use a fraction, and I think a good fraction to use would be 1.5. Okay. You could use 1.1, 1.2, 1.9, 1 3/4. Any number between 1 and 2 will work fine. All right, 1 minus 1.5. That's a negative 1/2. 1.5 plus 4, that's going to be a 5.5. And then 1.5 minus 2 is going to be a negative 1/2. Okay? Now, I'm not confused. I'm just thinking about something real quick here. Making sure I didn't make a mistake. 1 minus 1.5, negative 1/2. 5.5, 1.5, negative 1/2. Now, I know I really don't want to multiply a bunch of fractions, and there's no need to. The main thing we're trying to see is the sign. Is it a negative number or a positive? So if you take a negative number times a positive number, you'll get a negative, and then a negative times a negative is a positive. No positive number is going to be less than 0. It's not going to happen. So this section here does not work, okay? And then last but not least, let's test our blue section, which is, let's use the number 3, okay? So 3 minus 1 would be a negative 2. 3 plus 4 is a 7. 3 minus 2 is a 1. Well, negative 2 times 7 is negative 14 times 1 is negative 14 is less than 0. And that's true. A negative number is always less than 0. So this section here checks, okay? So let's get some room here. Let's grab this thing here, drag it out of the way, and pull this up here. There we go. So we have 2 regions that work. This one's a bounded region. It goes from negative 4 to 1. Notice I use brackets because it's inclusive and inclusive. And then over here we have an unbounded region. So I'm going to use a bracket for the 2. That's where it starts. And the 2 is inclusive. It's shaded in. And it goes to infinity. So infinity we always use parentheses. and there's your 2 answers. Okay, I hope this review video has been a help to you guys. Call or email Matthew Caleb if you have any questions. Don't forget your tests are due today, which I've not heard from any of you, so I've not heard from either one of you two, so I'm a little concerned there. So make sure you contact me if you need to ask questions, and we'll have one more video tomorrow and a exam on Friday. Okay.